So today we are going to be tearing down the Canon Avalon Nano3s, and we're going to be trying to make some upgrades and kind of tearing it down and showing you what it looks like inside. So I've seen a bunch of videos basically on this. I've fixed the whole showing it on the dashboard so we can have it on the computer, but that is because you have to scan an app and go into there. There's a lot that we can actually do with this, and I've seen some videos on kind of what to do. We're going to take it apart, look at the fans firstly, see if we could upgrade them potentially, and then we'll also look at, different upgrades. The one thing I do want to mention about the Canon Avalon is if you are going to upgrade it, you definitely are going to void the warranty. So we currently have it running at medium and it's sitting at 4.86 terahash, and then the watts is 94. But I believe if you're at 6 terahash, it goes up to probably around 120, 130. But we're just going to unplug this. So first thing, obviously, is... So we just unplugged the power supply. One thing I want to mention as well is this gets very hot. So I think the power supply is supposed to be used as kind of a heater as well as the Avalon Nano. So we'll see, kind of, let me know in the comments basically if that is true. This is kind of a heat sink as well to produce heat as well. So now we've got it unplugged, we can get into tearing it down. But first I want to thank the sponsor of this video, Crypto Miner Bros. Since 2018, CryptoMinerBros.com has been the premier site for top-tier crypto mining hardware, earning the trust of miners across the globe. The prices displayed on their site cover shipping and DDP straight to your doorstep, ensuring no unexpected costs at checkout. They deliver to over 100 countries and even provide lower invoicing options to help you cut down on customs fees. Payment is a breeze with options like direct bank transfer or cryptocurrencies including Bitcoin, USDT, or Ethereum. With over 250 ASIC options, they stock some of the channel's favorites like the bitaxe Touch, and the Avalon Nano3s. Join tens of thousands of happy customers who rely on CryptoMinerBros.com for dependable hardware fulfillment, clear pricing, and a top-notch service. Check out CryptoMinerBros.com today, link in the description. So we are back. First thing that this has is an air filter, which I personally don't think that this is too good actually, just based on the quality of that. It's not really stopping much from kind of what I can see. So we're probably just going to leave that off because it's adding to the heat of the actual miner and the chips. And then you want to take these off. So I believe that the bottom of them just come off, and then it reveals a screw down in there that we can take off as well. So we can just grab these off. The two here, I don't know where the warranty void sticker actually is, because on the previous version, so the Nano 3, there's actually a void warranty sticker that was in the middle, and if you pushed through that, there'd be a screw on the other side so they could know if you actually voided the warranty. Obviously, if you don't want to kind of mess around with it, then that's fine, because a lot of people don't want to ruin their hardware, but this is all in the name of science basically. So these are actually pretty tight in there, just these two ones at the base. And let's make a note of that somewhere. Let's kind of separate them. So one thing that normally what I do is when I'm recording these videos, to put everything back together, I just watch it in reverse. So I know where everything is. If there's like a bunch of screws, I know where they kind of came from, which is always good. And even if you're not making YouTube content, I suggest that you record everything if you're going to break something down, because it will allow you to just go in reverse and see where you put everything basically. So you have two screws there. These are actually very hot, so maybe we'll kind of wait for it to cool down a little bit before we open it up, or try to open it up. So these ones are a lot harder. I can't tell if I'm threading it or not, so I'm just going to take it out of frame for a little bit. So we've undone all of them. So if we just tip it over now, it should drop out. So we got 3 and I've lost one. But here we go. There's 4 here that we have, so that's perfect. And then I believe if we are gonna take it apart, you kind of need to pull this frame part off of the backboard. But I'm just gonna kind of press down onto here, like with a screwdriver, to see if anything pops in. Just because I think there might be a screw under, like that's what I would guess, is it's right there. But it doesn't seem like there is a screw under any of that. So we might just be able to pull it off. I don't think there's anything else. Oh, one thing that we do need to take off is this USB. And I do want to talk about this because the ping to the pool is actually not that great based off of this Wi-Fi that you have. So even with the bitaxes and the Nerd-QXs, it's substantially better in terms of ping to the pool because it's showing up as around 40 ms for these, at least on the dashboard. But for the bitaxes, I believe that it's lower. And it might be because of this Wi-Fi, that is plugged into the Wi-Fi right here. Sorry, there's a lot of exposure there. But we will take that off, so that's the first step, and then we kind of need to just shimmy it out, I guess. So the LCD is on there. It's actually very hard to pull this, so I might need to just pull it off of camera, and then we'll come back when I've actually pulled it off. Okay, so this is it right here. Sorry, that was very loud. So this heatsink is already very hot to the touch because it just was turned off. So let's go over a couple of things. Firstly, which is, let's start with the fans and then we'll move on to the board. So you have your fans in there, as you can see, and that is the shroud part of it. We do, if it is possible, want to remove this part, but it looks like it's just fully cinched in there. As in, it's 3D printed with that in mind, which is very annoying because I'd like to actually take that off. And one thing that we can, oh no, this one's cinched in as well. So that is, like on the previous versions, these were able to be removed. So this shroud part and then this shroud part were able to be removed if you opened it up, but it doesn't look like we can actually do that right now with this one. So you have your 3 fans in here. Now, because you can't set a fan speed, you can have them at 100% if you really want it to. I believe if you cut the yellow wire, which is going to be the PMW control, if you can kind of see that text in there, PMW lines up with that yellow wire. So I'm assuming that if you cut that yellow wire, it's just going to run based on the voltage that you're supplying, which is going to be basically 100% fan speed. And then this is the control for the Wi-Fi and then the power connector here. And this is the main thing that connects. So you want to be careful with this right here. So this is what connects the board to the other board basically. And that is the real tricky thing to actually get right on this. Now, another thing, I believe that if we look in here, you have the temperature sensor. So, the thing about the temperature sensor is that with the Avalon Nano, or any kind of Avalon heat mining solution, is that the software or the firmware doesn't allow you to run it at certain temperatures because it's in the firmware that if you drop below a certain temperature on a certain overclock, then it's going to kind of lower the amount of hash rate that the chips are going to produce. So the temperature needs to be high for it to actually kick in the settings to give you a higher hash rate, which is very annoying because with the bitaxes you can kind of do that customization yourself, and with the Nerd-QX you can do it yourself. But with this, it's solely based off of that. I'm sure you could run them way better in terms of the hash rate and overclocking if you didn't have that kind of temperature sensor. It'd be interesting to see if we actually unplugged that, what it would record to the chip. But I'm going to assume that that's not a good idea. So that is it in terms of all of this. Now, there is a couple of ideas that we have. Maybe replacing the fans, but it doesn't really seem like they kick in anyway. They're at 900 RPM on the medium setting, which is basically nothing. So I'd like to see them a little bit better, but because of that temperature sensor, that's just not going to kick in. The fans are just not going to kick in. You might be able to skew the temperature sensor and allow it to become hotter if you actually poked the temperature sensor through the kind of thing here. So let's just say, for example, you took it out. There is tape on there, so whatever. You took that temperature sensor out and pushed it through one of these holes. That means that the temperature would read by here instead of in there. And then that maybe, potentially, might cause it to overclock a little bit more. But obviously, these are made for a reason like this because of the heat dissipation that goes through. And it's really hard with these because you kind of don't want to take it out of this solution that you have here because it will mess up the temperature sensor. But I'd like to have some sort of open fan solution to this that we could maybe mount potentially in the future. But the only thing that's going to stop that is this kind of connection right here, which isn't very, that's very easy to bend any of them, and we don't really want to void the warranty on this. So now let's move on to the chips. So you have all of these here. Now we are going to be putting some heat sinks on a couple of places. I'm feeling like this is getting very hot, so maybe a heat sink on there and a heat sink just around these places right here, just to make sure that everything is very cool. I don't think there's any other potentials around here for heat sinks. On this one, there's potentially a heat sink that we can put down in there onto this thing right here. And then maybe on that as well, just to keep it all cool down in there. We'll have to see. So we are actually going to take this off and we're going to show you kind of what it fully looks like. It is still very warm, but you can see the amount of heatsink that is in there just for those chips. You can see it's double layered heatsink all the way around. So first two screws there, we can see just grabbing them out. So they got a little rubber thing on them. Don't know if you can see that. So, and then I think the next two are just these two here. So it didn't actually take much to unscrew these. So there's not a lot of pressure on them, which is a good thing. And then I'm assuming we can just pull that off there, and there you go. So here is the heatsink. Pretty standard, realistically. The chips are underneath there, so this line, and then the bottom is just a heatsink to keep the rest of it cool. You could obviously blow way more fans because these line up with the fans this side, I believe, to blow air through. And I think maybe the next step is to take this off and replace some thermal paste. I'm assuming there's also some really good thermal paste underneath, so I don't really think it needs a replacement, so we might not actually have to replace that. But the only problem with putting this back on without the plastic shroud is that it's not going to line up and it's all going to be weighted onto those pins that you see there. So you can't really flip it upside down. There might be a way, just potentially, to gut everything out of this and place that board on top of this one to have it very open fanned, but then this is going to touch the bottom of something as well, so I don't really know what we want to do with it. And then the temperature sensor, again, that is basically what it's running off, so the temperature sensor is always going to get in the way of kind of doing your own editing or adaptations to this. But I'd actually like it to be open, so we are going to try and take everything out of here and then place everything on top of here to get it to run again. So let's take it out and let's see if we can get it to run just plainly like this with the fans just facing it, and then we'll see if we can make a solution to actually, you know, keep it open frame. So let's go ahead and do that now. It's probably going to take me a while to take this out, so I will come back when everything is kind of taken out and we can remember all of this in our head. So first thing that I would personally do is going to see how the fans can be taken out. I'm assuming if we look in there, there's only 1, 2, 3, and then 4 screws there. Temperature control, we can worry about that when we've got it all out. This USB needs to move as well, and then the power connector right here needs to move as well. So there's also an LCD on the bottom of that, which I don't know if you can actually take that out. Anyway, let's kind of try take it all off, and then we'll see after that. So we have successfully taken it apart. You can see here, this is the control board. You can see your LCD there. Don't know what that is. That spring, maybe it's just to spring it on. LCD plugged in there. That's pretty much the front. So yeah. And then you have your temperature sensor and your LCD, or whatever that is. What is that? LED. If you see that, LED temperature sensor. Then you have your power, or fan, sorry, and then power by here. And then these are 3 pins, or not 3 pins, but all the pins that you have, and the USB stick. And then this, I've actually never seen that button on the Avalon Nano. It doesn't even poke through on any of these, so I don't really know. Maybe that's the reset button in this little pinhole that you see there. So let's get it to focus, because that's right next to the USB slot right there. And so the fans a little bit bigger than Nocta fans, I believe, but Nocta might make them like in this size, so there could be potential for upgrades there, or some different fans, but these actually are pretty standard. As I said, if you wanted to run them at 100% speed, then you could, if you cut the yellow wire, but I wouldn't recommend you do that. So we basically have to line this up again, take the temperature sensor out. I don't think we need the LED to be plugged in for it to start. So this is the LED connector, which just runs, I'm assuming, back through into here. And yeah, just temperature sensor, and then the power right by here. So basically what we're going to try to do is just plug everything back in and place this on top of the hashboard here and kind of see how it fares. So the temperature sensor is the main thing, because that's what's all going to run off. So we need to get that in the right placement, and then we can kind of go from there. So we're going to plug it in, and we need to make sure the fans are also blowing the same way. I know it's going to get extremely hot on the bottom of this, so we might need to find a solution just to hold it up and raise it a little bit, and then we'll go from there. So we obviously have this all set up. Very janky setup that we're seeing here. So this is all everything kind of exposed. So everything is plugged back in. We have obviously the chips underneath there. This is the board obviously facing upwards. The fans, I believe that they should be in this configuration, but I'm actually not sure because I forgot which way they're going. They might have to be, just looking at it, let's think about this. So you have that there. The heat comes out at this side, which means the fan should be blowing from here. So the heat comes out that side, which the fan should be here. So potentially we've got it in the right configuration there. And temperature sensor, let's bring it this way a little bit so you guys can see kind of the full thing. I know it's a bit overexposed right now. We had to tape the fans together because there's no kind of slot in for them currently. And this is lifted up just on 2 blocks right now. This is the temperature sensor, so that's going to determine kind of what we're looking at. So if we put it further away, like down here, then it's not going to record any temperature. But if we put it just there, hopefully the temperature does pick up from that, and then it starts. So I guess the only thing that we need to do now is actually plug it in. So moment of truth, realistically. and it's kind of a bit scary to plug this in, just knowing that I might have broken something. But the one thing that is not plugged in is this LED. So I don't know if it's going to run without this, I'm not sure, but I'm assuming that's to control this little button here. And if it needs that, then that's pretty stupid design, but we can go ahead and plug this in right now. So already, oh look, powered on, perfect. Okay, so make sure the fans, yeah, they're blowing. And it's saying hi. Don't know where the fan placement should be, maybe a little bit closer, something like that. I don't really know, because this is elevated here. Oh, right, that makes sense. Nearly forgot about this. Just going to unplug it to plug this in, because I don't want to mess anything up. So this USB, you can see how fragile it is. I should have plugged this in way before. Okay, so that's plugged in, and we can turn it on again. Get that going again. So assuming that it goes based off the temperature sensor, whatever, we are going to be able to see if it's going to produce any hash rate. Wi-Fi configuration. Okay, so that's good. It's connected to our Wi-Fi. It looks like it is running up, so we don't need that LED in there. Just going to do a little test. The one thing about the dashboard is it doesn't tell you the actual temperature, so it does tell you the fan speeds, but obviously going based off the temperature sensor, we're going to keep that just right there, and then we need to actually view it on the dashboard at some point, so we might have to record that. It doesn't actually look like it's doing anything right now, so maybe it's just warming up. It doesn't look like anything is hashing currently, so might need to give it a little bit to actually get up to there, and then we'll see from there. We've done something wrong in terms of the wiring, or the temperature's just not picking up. Okay, it's starting to warm up a little bit there. So we're going to let this run for a little bit. We're going to get the dashboard on screen, and then we're going to see how it kind of goes from there, what it's saying on the actual dashboard. So I'll see you on the dashboard. Okay, so we are currently here, and first thing I want to note is that the temperature sensor is definitely too far away, because it's not getting up to the correct temperature to actually fire on the chips. Because we're at medium or mid, we should be expecting around 3 terahash, but it's not hashing at that amount. The watts is obviously higher, and we need the fans to run up more because it's technically hotter. So there's a lot of things that you kind of need to kind of go with, and this dashboard is not great for displaying a lot of these things, like the temperature, internal temperature, temperature on the actual temperature control, things like that I'd want to see. So my method that we're doing right now is we're holding the temperature sensor way closer to the board, and then I'm assuming that that is hopefully going to give us more hash rate. So when we actually reload it, so yeah, we're back to 3, and that's probably because we have the temperature sensor right on the heatsink. So that means that it is running up to that, but the fan status is only 560. I don't know what the fan control is like in terms of the RPM. It must try to hit a certain temperature, so if it gets really hot, for example, it's going to try and cool it down quicker, but it is all going off the temperature sensor. So I'm assuming if you have the temperature sensor real close to the actual heatsink, then it's going to fire on the fans a little bit more. 700 RPM from these fans to try and cool it down, depending on what the temperature is kind of looking at. Obviously, the share is rejected. I kind of assuming that this is going to happen because it's not really functioning properly. Doesn't really look like there's much upgrades to kind of do on this yourself. Obviously with the bitaxe you can replace the fans, things like that, but with this it doesn't really look like it. The fans are pretty standard and it's all running based off the temperature. It is powering more watts into it, so we were sitting at around 94, and that was before we started. But maybe we can get the fans to basically spin up as quick as they possibly can. I'm going to do a little experiment here, which is that we're going to have the temperature control nearly touching the heatsink. And as you can see there, the fans are starting to spin up a little bit more, 800 RPM, maybe 900 it should go over to on the next reload. I'm really trying to get them to kick in so that you can get, you know, more fan speed on them. So if you add your own fans, the one thing is it's not going to operate at a certain temperature. It's just going to lower the hash rate. So I'm going to show you kind of what that looks like right now. What I'm going to do is I'm going to take the temperature sensor and just put it above, and then we'll see kind of where that goes. As you can see there, real-time hash rate 4.76, so it's actually very high, but we're just going to flick the temperature sensor, you know, way far away from the heatsink right now, and hopefully we see a change in the fan status because it's trying to keep it at a certain temperature. So we've just moved it away now, and in a couple of seconds I'm assuming that the fan status is going to go down, and so is the hash rate basically. Rejected shares, I'm kind of assuming that we're getting a bunch of rejected right now because the miner doesn't know what it's actually trying to do. So there you go. We've moved the temperature sensor away, so I'm assuming that it is going to come in very quickly. I don't know how long it takes to change the firmware on these, because with the bitaxe it's very quick. The firmware is operating very quickly in terms of how many times it's reloading itself, but with this it's maybe once every minute. If we go there, I would assume that the RPM on the fans is going to go down, or it might even shoot up because we have the temperature away, which means that it's 56. No, it's going to run lower, even though it's at 86 now. So maybe it's not going based off this temperature here. Maybe it's going based off of... No, it has to be going based off of this. I'm assuming in a couple of seconds we should see the hash rate drop off, the fans drop off as well, because the temperature is out of the range. Oh yeah, one thing as well, the ping to the pool. That's what I was talking about. Not very good in terms of these. The internet, or at least the Wi-Fi that you have provided, is not great. So if anyone knows how to fix that, please let me know. So I'm moving the temperature sensor way far away right now. We'll see kind of what the hash rate spins up to. See, it doesn't seem to be changing like quite at all. The hash rate is still shooting up whilst we have the temperature sensor away from the board. And I'm assuming that that is at some point going to cause, you know, some internal breakdown because it can't read the temperature properly. But maybe there's something in the software. If it's at a low enough temperature, it just spins the fans to make sure that the board doesn't overheat or anything like that. So yeah, it's still staying at around 5 terahash, which normally on the mid-range you're probably looking at 4 terahash, but this is sitting around 5. I don't want to actually put it up too high because that is really going to probably not be good for the miner, but this is just some kind of messing around, I guess. We could cut the yellow wire on the fans and basically take off the PMW control, but I don't want to risk that either, because if it is going based off the temperature sensor, then, you know, it doesn't really matter. Or you could upgrade the fans so they're a little bit more... The only way that I would see you getting more hash rate out of this is if you move the temperature control a bit further away from the heatsink, and then that in turn should allow your fans to run a little bit more, even though it's not technically cooling it if it is going based off the temperature sensor. Also, I don't know how you turn this off without unplugging the actual power supply, so can you turn it off on the LED? I'm not really quite sure. Yeah, I think that's kind of the video explained. We are submitting shares to the pool if we go to the pool right now. Currently on solohash.co.uk, and let's just fetch the wallet address here. So yeah, we are submitting shares to the pool, 4.37 terahash. Looks pretty good. That's pretty much it. So kind of what we discovered is based on the temperature control, but if you take that temperature control away, it's just going to try and function on whatever settings is in the default, I guess. It's just to stop this from overheating when the temperature sensor does break, if it does. There's not really much upgrades you can do to this, but we'll work on a solution. Try to mount it somewhere actually, maybe on a board, just to keep it kind of open fanned and a little bit cooler, because it looks to be running at a better terahash. And that plastic isn't very good. It kind of shrouds it in and makes it a lot hotter. That's probably the reason. So yeah, let me know your thoughts in the comments if you have one of these. I wouldn't recommend opening it up because you do void the warranty, but we just done it for the name of science, I guess. But yeah, let me know your thoughts on this, if you have any suggestions of what we can do in the future, and let me know kind of if you have taken it apart and what hash rate upgrades you're getting. Make sure you like the video and subscribe for more content like this.